I'm Anil Kumar. Welcome to my series on polynomials. We'll start with factoring. In this particular video, we'll learn about group factoring. So there are 6 questions which we will be answering to understand the topic. Question number 1. If a polynomial cannot be written as product of two other polynomials, excluding 1 and minus 1, then the polynomial is said to be what? Question 2. Find the greatest common factor of 4x squared, 8x cubed and 12x. Question 3. Find greatest common factor. Then write binomial in factored form minus 7x plus 21x squared. Question 4. Factor trinomial 3x squared minus 12x plus 18. And then the next 2 questions for us will be these 2, which is area of a rectangle is 21x squared plus 3x cubed. Find 3 possible sets of length and width of this rectangle. And question number 6. 2 flower beds are combined to form one rectangular piece. Find the possible dimensions of new area if the area of flower beds was 2x squared plus 7x and 2x squared plus 9x. Okay. So these are the 6 questions which we are going to answer in this particular video. So let's start with the very first one, where we are trying to provide you with the definition of factoring. If a polynomial cannot be written as product of 2 or other polynomials, excluding 1 and minus 1, then polynomial is said to be factored. What do we mean? Well, we have learned that if I have to factor, let's say 12, I could write 12 as what? I could write 12 as 4 times 3, so it is factored. But 4 can be further factored, correct? So this could be also written as 2 times 3. Now once you write like this, then we have kind of prime factors. It cannot be further factored. That's what we're trying to say. So in polynomials also, if we have a polynomial, let's say if we have 4x squared plus 8x, we could factor 4 and we could write this as x squared plus 2x, right? But remember, you could factor x also. So it is still not factored fully, right? So it is factored fully. You can say that. But factored means that you cannot factor it further. Okay. So we have to take that x also as a common factor, and then you get 4x as a factor, and the other factor is x plus 2. Now you cannot further factor it, correct? So that is what it means. So to factor polynomial, we really have to write in a form that it cannot be further multiplied by 2 other factors. Obviously, you could keep on writing 1 by the number itself, and therefore 1 and minus 1 has been excluded. So I hope this definition is absolutely clear. Now let's take up the questions one by one. Question number 2. Find the greatest common factor for 4x squared, 8x cubed and 12x. Well, clearly, x is common as far as the variables are concerned, and as far as numbers are concerned, 4 is common. So 4x is the answer. So the greatest common factor is 4x for question number 2. Correct? Question number 3. Find greatest common factor, then write binomial in factored form. So here we have minus 7x plus 21x squared. As far as numbers are concerned, we'll take minus 7 as one of our factors, and as far as the variables are concerned, x is also a factor, and therefore minus 7x is the greatest common factor, correct? So we have done part 1. Now the second part is to write it in the factored form. So we could take the common factor. So let me rewrite this. So minus 7x plus 21x squared can be written as minus 7x is common factor. If you take them both as common factors, then you get to left with 1. You divide this by minus 7x, you get 1. Here, the sign changes to negative. 21 divided by minus 7 will give you minus 3. X squared divided by x will give you x. So we have minus 7x times 1 minus 3x as the factored form. I hope that is absolutely clear. Now question number 4, we have trinomial. That means we have 3 terms. So binomials, this is example of a monomial, right? Let me write down these terms also. They are very helpful. So these are monomials, right? Greatest common factor of monomials. So, right, so each is a monomial, correct? 1, 1. Now here we have binomial, 2 terms, right? So that is called binomial. There are 2 terms. This is the first term, that is the second term, right? So binomial means 2 terms. And now we have 3 terms, so this is called trinomial. Okay, so let's continue. We need to factor the given trinomial. So here 3 is common, as you can see, but nothing else we can take common. So we'll just take 3 as common, and we are left with x squared minus 4x plus 3 times 6 is 18. So that becomes the factored form of the given trinomial. Now this kind of factoring which we have done in this example is called group factoring. There are other kinds of factorings which we'll soon touch upon, but I hope you got the basic starting point, group factoring, right? Now let's take up question number 5 and 6, which are applications, right? So we'll now take applications of this particular result. Question number 5 and 6. Question number 5. Area of a rectangle is 21x squared plus 3x cubed. Find 3 possible set of length and width of this rectangle. Question number 6. 2 flower beds are combined to form one rectangular piece. Find the possible dimension of the new area if the area of the flower bed was 2x squared plus 3x and 2x squared plus 9x. You can pause the video, answer these questions, and then look into my suggestions. Now we are given rectangle with 21x squared plus 3x cubed as the dimension, as the area. So this is the area, right? So let us factor this. So if you factor this, 3 is common and x squared is also common. 21 divided by 3 is 7, x squared divided by x squared is 1. Now here we took 3 common, so number is 1. X cubed divided by x squared is just the number x. So we get that as a possible combination of length and width. Correct? So one answer is, since this is our area, we have length and width combination. Now let me write down 3 possible sets. Let's try to understand how to write 3 possible sets of length and width. One is direct. We got this result, which is length could be 3x squared. In that case, width is 7 plus x. Now what else you could do? Well, what you could do is you could take x squared as length and 3 times 7 plus x as the width. So you could combine them. Do you get the idea? Or you could take 3 as the length and multiply x squared with 7 plus x. Does make sense to you? So these are the different combinations in which you can have a rectangle once you factor it. Correct? If you're not able to factor, you could also write one dimension as 1 times the whole number, which is 21x squared plus 3x cubed. That is also a possible combination. Length could be 1 unit and the width could be everything else. Now this is a very important combination, since at many times you may be tricked and you can get a function or you can get a polynomial expression which cannot be factored. In that case, 1 times the number itself, remember that. So 1 times the polynomial itself will be the possible combination. Perfect. Okay, so let's move on to question number 6 rather. Two flower beds are combined to form one rectangular piece. Find possible dimension of new area. We are given two areas, right? So let's add the two areas. So one bed is this one, the other one is that. So we'll just add them up. So we have 2x square plus 7x. Now adding means combining like terms. So we have 2x square, x square makes them like terms. We get 4x squares. 7 and 9 combine to give 16x. So that becomes our total area, which could be factored. 4x is common factor. You get x plus 4. Do you see that? So that is how you could get the new plot, right? So that basically means that you have something like this. A rectangle plot whose one side is, let's say, 4x and the other side is x plus 4, correct? Now, let us say if I add part B to it, and that is draw original flower beds. How will you do that? We got the combined part. How are you going to do that? So think about it like this. Since we had 2x square, so one is x, right? So it could be kind of like this. If you divide this, then each is 2x, correct? To get 2x square plus 4 kind, right? So we have to have, let's say this is x for us. So if I have this as x, then these areas are 2x square, correct? So what is this area? These areas are each 2x square, correct? Now, plus 4, that means to say that horizontally, we have divided this to x and then these are 4 pieces. So let me just make quarter. So these are the 4 pieces. Do you see that? So you get x plus 4. So one of the areas of the flower bed is how many pieces? 7, right? So we have in all 16 pieces. Each is times 2, right? So it's like this, x times. So let me just go like this. Do you get the idea? So now you got 16 pieces here, correct? So one of the areas will be 2x square and you need 7. So 1, 2, 3, 4, 5, 6, 7. So I can mark the area as this. Do you see that part? So this portion is one flower bed. So I hope you are getting this model, right? So which is 2x square plus 7x. Correct? As far as the other flower bed is concerned, you can see the remaining portion is basically 2x square plus 9. This is the extra one, right? So 8 and 1, 9. So that is how you could actually combine these flower beds and get your result if required. Perfect. So sometimes we may twist the question and ask you to provide us the layout. So that could be a possible layout. I hope you understand and appreciate it. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Watch our list on practice on group factoring and other kinds of factoring of polynomials. Thanks and all the best.